Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to do two real quick and simple concepts. The practice is so simple, I just have the answers because it's real basic algebra. We're looking at something that I actually never got the first one until I started teaching advanced chemistry. It was in the Brown-May book, so I included it. It's a very simple. The first concept we're looking at here is called Henry's Law. Henry's Law defines means determining solubility, the relationship between pressure and solubility of gases. So this is only involving gases and their solubility. So the equation itself is S of G, which means the solubility of the gas is equal to K, which is a Henry Law's constant, times the pressure of that gas. We take the pressure of the gas times the constant, and we get the solubility of that gas. All right, now, let's take a look at a simple problem here. Determine the Henry Law's constant if nitrogen is dissolved in water such that the molarity of the solution is 0.09877 molar and the pressure of the gas is 0.687 atmospheres. All right, so we start with our equation. S of G is equal to K times P of G. We're going to solve for K, of course, so that means we're going to divide through. S of G is on the opposite side, so P of G is going to come down. So S of G divided by P of G. S of G, these both are nitrogen. So S of G is, S of G, the solubility of the gas is the concentration. So that's 0.09877 molar. The pressure of the gas of the problem is 0.687 molar. So we have 4 sig figs, we have 3 sig figs. Least number is 3. So we're going to end up with 0.144 molar per atmosphere. That's my Henry's Law constant. All right. Now the other concept we have to work with is something that you do if you really want to do a quick dilution. You don't want to make another solution up. I often do this. I have a concentration of like 3 molar hydrochloric acid, and I want to make 1 or maybe 0.1. I will use this equation to dilute down the more concentrated solution in order to work it that way. So to do this, we're in the process to reduce the concentration of a solution. The equation here is M sub 1, the concentration of the molarity of the what we're starting with, times its volume is going to be equal to the molarity of what we want to get to times its volume. So that being said, let's look at the problem. Find the concentration of 250 milliliters of the solution if 100 milliliters of the solution, if 100 milliliters has a concentration of 2.500 molar. So molarity is equal to M1 V1 is equal to M2 V2. M1 we don't know. That's what we're looking for. 250.0 milliliters. That's the volume we are going to get to. M2 is 2.500 molar. And 100, that's all we have. So sig figs, that's going to be an issue. So we are looking for M1. That means M2 V2 stays on top. V1 is going to come down. Plug our values in. My milliliters cross out. I'm left with molar. I only get 1 sig fig because 100 milliliters only has 1 sig figs. That's as accurate as it can be. So 1 molar is as confident of the answer as I can be. All right, now, to be honest, you don't do this way very often. You're more likely to do this way. This is what you end up doing more often. What volume do you need to make 1.255 molar solution? If you start with 350 milliliters of 3.000 molar solution. All right, guys, I made a mistake when I was recording this, and I decided to be simpler to explain it here. I just have the answer. I don't have any work. So what I want you to do is pause the video, give this a shot, see if you come up with the answer. Okay, so take the time, think about it. We're looking for volume, so it's the same thing we did last time, except we're solving for V1 as opposed to M1. All right? Ready? All right. So, work that through. That's our answer. Any questions, let me know. Only 2 sig figs because of 350. All right. With that, we're done. Take care. God bless.